Hi students. Now today we are going to study about characteristics of a sound wave. You would have seen different sounds are different. How do we distinguish one sound from another? For example, the sound of a bird and the sound of a horn and the sound of a small boy. These three sounds are very much different from each other. Now, why are these sounds so different? Or how do we distinguish between different types of sounds? How do we characterize a sound wave? So, a sound wave is described by a lot of parameters like amplitude, wavelength, frequency, time period, pitch, speed, and quality. Now, whenever we say two sounds are different, that means those two sounds must be different from each other in one or two of these characters. Before we talk about each of the characteristics of sound wave, let's recall how exactly the sound waves are formed. Why do we call it a wave? Whenever we say a wave, this is what comes to our mind. So how this variation comes into picture? This is how it comes. Say if this is the source, say here I am having a speaker and this is the source of sound and human ear is receiving the sound. In between this, how are these sound waves traveling? In the form of disturbance. It's like a disturbance which makes the particles of the medium to vibrate. So here these dots here represents the particles of the medium. So in one of our previous line, I told you how particles vibrate. Now when you look at the overall picture, you will see that in some regions the density is very high and in some regions the density is quite low. Again there comes a region where density is high and the density is again low and so on. So here we have more number of particles in high density and here we have less number of particles in less density and so on. So based on this density of particles, this plot can be drawn. Here you see as particle density increases then comes down and so on. Where density is high, these regions are called compressions, and where density is low, the region in which particles are spread, this region is called rarefaction. Then again compressions, then rarefactions, compressions and so on. So alternate compressions and rarefactions form a sound wave. So you got a plot like this. See, this is the time axis and see, it increases. Now what increases? So we'll try to understand this graph. Here on the x-axis we are considering time. So with time, this is how y-axis is varying. Now what is there varying? That is amplitude on the y-axis. Now you might be curious to know what is amplitude. That is what we are going to understand. When we talk about a sound wave, sound is always about how loud or soft the sound is. Now the question is, what determines whether the sound is loud or not? So that is determined by amplitude. Amplitude determines the loudness or softness of sound. So what factor does it depends? It primarily depends on force with which an object is made to vibrate. Now, for instance, if I tap this notebook, if I tap this, that means when I tap this, that means something is vibrating, and that vibrations produce sound. If I tap this very hard, in that case, I'm applying a greater force, and when I apply greater force, that means the vibrations will be very more, and sound produced will be louder. So let's look at this example. In the first scenario, if you very gently tap the table or tap this notebook, so what will happen? The sound produced is also going to be very less. In this case, force applied is less, so amplitude is less, and therefore loudness is also less. Okay. And if we take the second scenario, if I tap the table or if I tap the hair extremely hard and fast, so in this case, force applied is more. So sound produced is also more, and therefore amplitude is more. So the loudness of sound is directly proportional to amplitude. Greater the amplitude, louder will be the sound. Now let's try to understand this in terms of vibrations. Because whenever we talk of sound wave, it's caused by vibrations. So how is this amplitude associated with vibrations? When to and fro motion happens very fast, that is vibration. So if you look in this, this is the central position or the mean position. So it's going to say it's going in, say, this direction, one direction, then to extreme direction, and it will come back to its mean position, to its central position, then going to other direction, again will come back, and so on. This is vibration. Now what's happening in the entire scenario? From central position, here it moves to the extreme position. So this is the maximum distance which it travels in either direction. This is the maximum distance, or when it moves here, this is the maximum disturbance. So this maximum disturbance is known as amplitude. And now, how does it depend on force? Let's assume that a pendulum is in our hand, and when it's at the central position, say you apply a force in one direction. Suppose you pull this pendulum to here, you applied force and take it here, then you will release it from here. Now what will happen? It will start moving and it will cover this distance, and it will cover the same distance from here. And this distance is nothing, this displacement is nothing but the amplitude. And whatever will be your force, same will be the amplitude. If your force is more, your amplitude will be more, and if your force is less, your amplitude will be less. Say for instance, if you are applying lesser force, so see, it's covering less distance, displacement is less, so the amplitude will be less. Now if you apply greater force, suppose you are taking it here and then you will leave from here, so see, it's traveling more displacement, and when it goes here, it will travel the same distance as it travels from here. So if your force is more, and then if you are applying greater force, then it will cover greater distances in both directions, and if you are applying less force, it will cover smaller distances in either directions. So your force applied is directly proportional to amplitude, and as the amplitude increases, vibrations will increase. Now loud sound travels larger distances and vice versa. So if you tap the table hard, the sound will be heard over large distances. Maybe you are in the study room, so your sound will reach to your living room. If you tap it very gently, maybe somebody sitting next to you might not be able to hear it. So if the sound is loud, it travels over large distances. So therefore, people at distant places can also hear it. So this is amplitude. So when we talk about amplitude, how do we define it? It is the magnitude of maximum disturbance in the medium on either side of mean position. So let's look at it. Let's look here. So when we this is how entire light on amplitude looks like. So when we talk about vibration, say this is one particle, and say I'm applying force, and this particle will vibrate in this fashion, like this is going to the maximum disturbance, say on either side of the mean position. This is the mean position, it will go to this extreme end, then it will come back and go to this extreme end, and the distance, the displacement it travels on either sides of mean position are termed as amplitude. So maximum disturbance which it travels in either directions, that is amplitude, and it is denoted by A. The SI unit of amplitude is meter. Now when we measure amplitude graphically, then how does it looks like? Okay, this is how it looks like. So when we talk of low amplitude, it will look like this. This represents its mean position, and here the amplitude is 0, and this is the maximum distance traveled, and the amplitude is going to be A, positive A, and here it is going to be negative A. Now if the amplitude is very high, the plot will be like this, and see here the distance traveled is less, so amplitude here is less, and the distance traveled is here is more, so this is the high amplitude here. This is all about amplitude. Now next is the wavelength of the wave. Now what is wavelength? Now if you look at the wave, you will see that a wave will have an upper portion and a lower portion. So this peak of the wave is called crest, is termed as crest, and the valley of the wave is termed as trough. So any wave is alternate crests and troughs, and so these crests are caused by compressions, and troughs are formed by rarefactions. Now, what do we mean by wavelength? So wavelength is the distance between two consecutive crests or two consecutive troughs. So this is first crest, right? And which is the next crest? This is next crest. So the distance between these two crests, this distance is known as wavelength. Even distance between two troughs, this is one trough and this is another, and distance between these two troughs is also known as wavelength. So basically you can say the entire distance covered by one wave is termed as wavelength. You can say like the distance of this crust and the distance of this trough. This distance is also termed as wavelength. So, uh, so if you see, each of these intervals are equal. The time from here to here is equal to the time to here, and this is equal to this time here, and this is equal to the time taken till here. So these are like equal intervals of time. So that is why it's a periodic motion. So if we measure the wavelength, distance between two crests is same as the distance between two troughs, and so that's wavelength. You can also say that distance between one crest and distance between one trough, this distance is also termed as wavelength, and wavelength is denoted by lambda, and it's measured in meters. This was all in about wavelength and amplitude. Thank you.